Hello everyone. Welcome back to another session of Code with your friend. In our previous session, we started understanding more about linked lists in C. Our focus was a linked list with just integer value, and it was also a single linked list. We ended up replicating the Java linked list APIs to see what are the different kind of operations that we can add on top of linked list. It did not make sense to implement the APIs as is, but it would give us like a good sense of what possible operations are needed because once they have designed their APIs and it's quite well supported, we can take our learning and rather than like picking our head about it, we can just use the research and add those APIs in C. Is it a good thing to do that, replicating? I don't think it's like a really necessary thing, but it's more for our exploration and it's fun. So just take it with that. And if you are sort of following this video, try to code it yourself. Clarify your understanding the same way that I'm trying to do mine, and hopefully it'll be useful. So without much delay, let's get started. And I think our recording is working fine. So it's actually split the screen. I think that's a better way if I can sort of be able to split it. Yeah, I think this is better. We don't need that much of content on the left side. Just editing the browser is fine. So this is I guess perfect. So we implemented till remove first. Um, then there is also a part of remove last. So the way we implemented remove first was we passed the head reference, and in this case also we have to pass the head reference, even I think the pointer to it, because potentially there could be just one element, and if that one element is removed, the head pointer needs to be modified. For remove first, the head pointer will always be modified, but in this case, maybe they could be modified. Uh, and we just need to check that upfront. So what we would do is like we will say head next. If that is null, then we'll just free head and we should return that. One thing, if this is not actually checking even the remove first, if head is null, then we should not be able to remove anything. So in that case, it should return -1 or something like some wrong value, something like this. Same I think goes here. If this dot is pointed to it is null, then return int min. Otherwise, we would check if the next of head is null, then we will free this one. We will also verify this is the right way to free it, or rather we can do like a proper dereferencing part. Something like this, right? So head is a pointer to pointer, but then temp is just the one level pointer. That's why we are dereferencing one here. If we don't do that, then probably it'll just throw an error that it can't do an assignment, right? Yeah, that it can't do an assignment. So we have to dereference here. Once we dereference and we see if like just the next pointer is null, then we can just free that. We can return one, but if that is necessary, that's essential. We don't need to return one here. We actually need to keep the value and then return the value. Same thing probably we would do for the other cases. We want to remove the last element. So see if we temp next is not equal to null. We will just keep on going like this. And I think it's actually possible to just do it here. Okay, yeah, so I think if temp next is not null, then we will iterate that. If in the first case, if it's just one element array, then probably we just need to remove it, and we say if it's free temp. The only thing that is possibly problematic, because we are not actually modifying the head in that particular case. So let's see, actually, rather than speculating, let's just see. So we'll keep it till here, we'll do a print list, then we'll do a remove last. So printf remove last head. What does this provide? So remove last is this, but what is my print list after that? Yeah, this is completely messed up, right? So it is not right. Ideally it should end here. So the reason that this is a problem is because I think for not null case this should not be that complicated. So there is some very basic error that's happening here. So we have this temp next and we are finding till we go to 50, and do we want to go to 50 then? I think we want to go to this, right? Isn't this the right thing to do? If we, I don't know what is we are pointing here. Um, if the free is working fine, we'll check that. And the question is, now I think this is sort of makes sense. If there is a only one element, if 10 next is null, then we need to keep the value first. We will free 10 and we will but head has null there. We also need to return refine here. So this is for the first element. If there is only one element, this is if the list is empty, and this is the remaining sections. The best thing would be just to iterate over it. While head is not null. Should we do that? And after coming here, should it be, yeah, it's fine. So seems like we are doing fine, right? The only thing that needs to be tested here, if the free is working fine. If let's say in both the cases I can check, I can pass in temp val here as well as temp next val here. So it goes with a segmentation fault, but if we don't do a free, that's also going for a segmentation fault. That's because I think because the next this thing is causing this segmentation fault here, right? Because we are putting a null. If we don't put a null, then it's pretty problematic. So how to test if this free is working? I guess for the one element we can check probably. And if we don't free, if we yeah, I think if we free, then it probably it's messing up. So I think this free is working fine. So then I think we are good. Then I think we're good. If we don't free, then it's returning proper. Yeah, awesome, perfect. Yeah, it's good to see. I think if this way you can test internally, the best way is to see. I mean, even there could be some bug which I'm not aware, but at least in my current mindset, this is working fine. So we have implemented quite a few APIs. Now let's go move ahead. At first, I think we already have. At last, we already have contents. Contents would be quite similar to index of. So we can have potentially a contents here. C does not have a thing of boolean, so we'll need will be quite straightforward. So since we have implemented index of, we can just reuse that. If index of is not equal to -1, then it means it contains. So size, I think it's an interesting thing, but also quite easy to figure it out. Size is 0. It is not null. Head is head. Next, and we implement size here. Let's also keep on printing the size here. Percentage size head. Okay, where is this? Size. So after remove last, so we are doing size after that. So let's do backslash and probably it's easier to see. So we print the list and we first print the list. That's I think first print list which is outside. Print list inside. So after first element removal, size is 4. This is the list. Should we just do print list before? So yeah, sure. We got this, size is 4. We got this, size is 3. We got this, size is 1. We got this, size is 0. So just working fine. Add is already there. Remove. I think we have implemented remove last, remove first, or size. So I guess remove would be very similar to remove first. What we need here is, or rather it should be very similar to remove last. But we need to check here if you're matching, like any value, if being matched, then probably we just need to remove that guy. So I think if we can just do it in one pass, or we can do it in multiple passes. I don't think there's any point doing it in multiple passes. Though clear I think is like a very good example. So let me implement clear first, because I also want to test my remove. So clear can be implemented in two ways. We can remove all the elements. We can remove the first elements. So let's say like this, we have something like this. What will happen? Not remove last, remove first. So let's see. So we have this, all these elements, then we first remove this 150, size is 4, then this 40, 30, then size is 0, then we again add all of these guys, and we remove 10 first, 20, 30, and then. So essentially, clear can be implemented by either of the two ways, and I prefer just, let's do it in remove first way. So avoid clear. I need to have the like this. While head is not equal to null. Okay, just call remove first address. Or rather, yeah, I think clear should be passed as address to address head. So I think this is pretty simple, right? We can call it, let's say, add all. And then we can just call clear address of head. Then we do another add all. We got a segmentation fault. Interesting. So I think the segmentation fault where I think this clear is coming for segmentation fault, right? Do we get like this? Okay, so I think we can get a segmentation fault where it's happening. So the clear is up, yeah, of course. So I think it's a very bad mistake, and I don't know what I was thinking. The mistake that's happening is while head is not null, and then so we need to keep a reference of next, right? Because every time we are going to remove it, so it's going to be problematic. So in that way, probably remove last is better, right? So if remove first is there, then head is going to be modified. So my assumption is like at the end, we'll have head will be assigned as null. Um, what if we just do it by remove last? Do we also face segmentation? We face segmentation, or here we're not facing segmentation fault. So this one actually removes the last element. But I think we have to do it for some number of times, right? So for that, what we need is we first need to get the size of it. Just get the size of it, and then say while size is greater than 0, you keep on decrementing size. Right? What about that? Size 0, so we can clear them. So after initialization we have that, then we clear it. So it's just two pass. So in the first pass we see how many elements are there, and then we keep on calling that many times of remove last. Yeah, I think this should work. Public get index. I think one function which we haven't implemented, probably I should put a stub for that, is remove. That should also return remove integer p perhaps. Let's actually implement this now. How we can implement this? So we have like remove last and remove first, something like that. So in this case, we need to obviously pass like the L node reference to reference head here. And the first possibility if the head itself is, so we can actually reuse some of this stuff. So if let's say this val is v, then what we can do is we can just do a return remove first head. So that should take care of the first part. Otherwise it's quite similar to the remove last, except we have to iterate the list here. So lnode pointer temp is, let's say, head, while temp is, let's say, temp, next is not null, if temp. So there are two ways we can possibly break here. If temp val is equal to v, then also we can break. Otherwise we can just do like temp so if temp next is val, if temp next is not v, if temp next is null, and then temp val is v, then what we need to do is we actually need to free that pointer. So temp next is val, and temp next val is, because we have to point the previous one to the next structure, because if it's at the middle it should be like, in this case, if temp next contains val. So this is the case. If temp next contains val, I think this is still, I think, problematic, because if there is only one element, then it should be the case. If there is no element, then we should return like int min. So 0 element, 1 element. Now I think there is at least 2 elements here, and the second element could be the case of, if more than 2 elements, then it could be like second or any other element. So if the second element is the value, then we need to keep the value temp next val. And what we want to do here is we definitely want to free temp next. So temp next going to be temp next. Can we do this free temp next? And then temp next will be temp next. I guess it won't matter, right? If it is only in the case of this. If temp next value is v. So either if it's like a last element or some middle element, it won't matter. we just keep it and then we return v. Otherwise, should return -1. But this is like a tricky thing, right? So this has lot of conditions, so it needs to be tested really well. Let's actually test this. So we have tested this bunch of other functions. Let's just remove them now. So if head is null, if there is only one element, then we sort of match it. And what if, I guess there should also be a condition if head next is null, that should actually imply there is only one element. And within that, if the first element is the case, then it should be there. Otherwise, it should be just -1. The first one can also be like -1, something like that. Yeah, I mean, error condition, we can call it by -1. If it's not found, but we can simplify later on. So temp, otherwise we will have like at least two elements here. So good, temp next is not equal to null, and temp next val is equal to v. And we break out of here, and we always iterate over the next elements. So in this case, temp next val is equals to v. So this is, I think, the case that we want to check for. Otherwise, if it's not the case, then we are just at the end of the element. We just have to check that. Then we keep that value, then free temp next, and then do that. Let's actually test it out. So let's say we first ignore the return value. First head and then say remove just 20. Conflicting types for remove. (130) and 146. 130. STT.h. Oh, okay. Remove file name. Then call it probably remove value or something. Remove val. No segmentation fault, but did it remove properly? Yeah, it's able to remove properly. I think we can also say the index. True if the list contain the specific element. So yeah, I think we can just remove, say, let's say just 0 1 thing, right? So, or I guess like the better way is if you can specify the index, then I think it's even better. So first documentation. Returns index if value if v is removed. So -1 is an invalid case. What does remove first do? Remove first. Um, yeah, remove first actually won't do that, right? Because we can call remove first here, but we can actually test this same way. We can say for 2 or more elements. Integer index 0. So it's definitely not the first element, but if it's the last element or not, I think that's the question. Then I think we don't need to do that even with this. For 20. 20 will be returning hello. Let's do a print list of head. Even after this, we'll do that. This is messed up. So I think this removal is going wrong here. So we can go into a debug mode because this is like a, I guess for linked list probably this is one of the complex functions. So we are sort of finding it, right? For example, here is free responsible for that. Seems so. So indexes definitely should be on, and if let's say I'm saying 30, index is returning proper. If I'm saying 40, that's also fine. And if it's 50, that is I think where the edge case testing will be. Seems fine as well. So I think we can sort of rely that this is working. Let's see. Let's actually um, let's do this twice. So we'll do an add all, then okay. What basically we want to do is just the other element. So this will be just removing the first element, which will be quite straightforward. Always the first element is removed, and I think this is always the last element should be removed because we want to start from the last element and then we want to go down till the first element. So 5 elements we want to remove from here and also keep on printing the listing again. Let's see. So we have 10, 20, 50. We got a -1. Okay, interesting. Then I think, interesting, 10, 20. Eventually we have like this, and then we do an add all, and we remove 50, we remove 40, we remove 30, 20, 10. So the first element removal is not working. If we send 10, if we send 10, it's not working. If there is only one element. That's okay. I think this is interesting. So this should be actually reversed, I think. If we have just this one element, then we should just remove first. Ten, 20, 30, 40, 50. Print list. Print list, actually, let's remove this, right? Just do a print list at the beginning. And same for this guy, just do a print list at the beginning of the loop. So we have 10, 20, 30, 40, then we have 20, 30, 40, 50, then we have 30, 40, 50, then we have 40, 50, then we have 50. Okay, then again we have this, then we remove 50, 10, 20, 30. This is actually perfect. This is perfect. This is what I'm expecting. Now I think our functions are sort of working fine. So we have implemented remove, we have implemented add all, and index inserts all of the elements in the specified collection to the list starting at a specified position. This is actually interesting. So our add all assumes we would just add at the last element. But is there any other add function? Should be add at index, right? So I think if we implement add index first, it will be easier to implement add all index. So let's just do that. So add index. We also need to provide the index here, right? We can reuse in whatever way. I mean, if add index was implemented first, then add first can reuse that. But since I had implemented add first. So if index is 0, then essentially it's just add first, head and b, return, right? Otherwise, index is not 0. Then what we can do is, if index is, what happens if index is out of bounds? Should happen, right? I can't tell. Returns 0 if of success -1, otherwise this should be a success. And I need to get the size first. Or is it necessary? We can't just do it in one pass, right? Add first is taking care of even if you have like empty, so that is actually fine. But if it's not the case and we still have probably we need to return -1. Otherwise I think we are good. We can just dereference it. We can say well temp is null equal to null. Second next is not equal to null. Temp is equal to temp next. We also might need to have one counter kind of here. Keep on interacting with that. If I is equal to index. Now temp I think will point to head, right? So if I is equal to index, then we probably need to create a size of L node and new value will be fee, new next will be actually define this one early on here, right? And we can see just that the new becomes this new malloc, and we can just break out of it. If we come out and we still see that new is null, then we just return -1. Else, so we always check if so in this particular case here new next will be temp next and then temp next will be new, right? It's a new calibration, so it should be fine. Otherwise just return 0. Well, I think we are returning this wrong, right? So it's a true false case, so this should be false. So you should indicate false. So we have add index, node head index v, and first return 1, which is true. Then we have index head is null, then return 0. We iterate that and we don't find anything. Is there a possibility that you might want to insert at the end you might insert at the end, right? Because if, let's say, you have 4 elements and you say index 3, let's just run it. I think it probably will fail. This is, I think, good. Probably can remove some of them. Here, add index. Index we have to provide here. So the same index will provide. So the first one, I think it's not registering. So what are we providing here? Index %t. So let's go I here as well. So index. So provide if index is 0 and array I think is 10, then we are able to insert this. This is my list. But so the first insertion is happening fine, but the second insertion is failing when we are appending at the end here. Yeah, so I think that's sort of expected. What we have to do here is what we have to do here is we have to just do a little bit of check if index, the same thing basically. If I is equals to index, then we'll do a new value. Then we do new next is send next, and then instead of break, we'll just do that. That should actually return 1. Other than that, I think it'll return 0. But I don't know why we should return. We should come here in case this break thing. We can just return directly from here, right? So this remains just no failure scenario. So there's just one element. So we start with I, and then temp next is null, and I is not increased. Okay, got it. So if we start with 1, then that is also sort of wrong, right? So this check is actually not correct. Ideally here, if we have more, if we are actually currently here, then probably I plus 1 should always be index, but maybe. And what if an ad hoc thing happens? For example, if I just say index 3, or I guess like add last is working fine, only the middle part needs to be tested. So index 3, and then I want to enter like 35 or something. It's not actually entering at index 3, right? It's actually entering at index 4. So should it start from 1 then? Because I think the 0th one will not be ever checked. So we know I is always 1. Let's change this to 0. Works fine. Let's change this to 6. Works fine. Let's change this to 5. Works fine. Works fine. I guess like if we had sort of a unit test setup, then it would have been better. But so we have add index also. Now we have, I think, tons of APIs implemented. Is there anything else that needs to be implemented? Probably we can do documentation. So remove index of, last index of. This is actually interesting. So let's actually write down what are the things we want to implement. So probably the last index of node head integer fee. Peak. I think this is sort of similar as we can implement a peak, but it does not remove, so I think it's not required. Peak is actually just get first, right? So I don't know why we need it. Okay, I think these are just similar. Offer first, offer last. It's the same thing. Peak first, declare folders. I guess these are like just a stack implementation, and first occurrence, last occurrence. That's the similar thing. Iterator. Iterator, I think it doesn't make sense to do it for C. Clone to array. To array, probably. Yeah, I think it's a good one to have to array. To array. Clone. I think a clone would also be good. This is fine. So I guess like then we have like just like 3 APIs more to implement, but we are out of time today, so we'll end the session now. But next session we'll try completing these 3 implementations. Then we have like a significant amount of linked list APIs implementation done. That should be sort of a good step for our, the next iteration that we have planned for this session. Thanks for joining in. See you in the next session.